Hi, in this video, we're going to talk about functions, the basic definition of functions. So let's get straight into it. If you were to call a textbook definition, a function is a rule that associates every element of one set with one element of another set. Let's try and picturize this thing. It's a rule. It's a rule. But then it says between one set and another set. Okay, so it's kind of saying that there's an association. Can you see that word? Sometimes we use the word there's a relation. There's a relation between what? Between one set and another set. These are the keywords we can pick up, correct? So we'll say there's a relation, meaning, okay, let's me call that set 1 between one set and there's another set 2. Okay, let's make it in the view, bring it into the view for everyone to see. Okay, so set 1, set 2, and there is a rule. I'm going to just make some sign and say, okay, that's that blue arrow is the rule, and let's just call it rule that associates. Let's get back to the definition. What did it say? It associates every element of one set with one element of another set. So we've got set 1 and set 2. They've given us special names for set 1 and set 2, right? The special name for set 1 was what? Domain. And the special name for set 2 is range. So look at the definition. So we are visualizing a function is a rule. The rule, we've given it a nice blue color arrow. Associates, that means it links, it's connecting, relates. That's where you get the word relation from. Every element of one set called the domain. So we've called the set 1 as domain. Another set we call it range. And right now it looks empty because we've not put any elements in that. So let's try doing that, okay? The blue one is the rule. If I just say the elements here are 1, 2, 3, 4, and I say some elements here are, let's say 1, 4, 9, 16. Now, let's try and visualize a rule, all right? So if my rule is visualized by the same arrows, okay, so I'm just going to use another color here to say, okay, the rule is that 1 gets, is related to 1, 2 gets related to 4, and I'm deliberately doing that squiggling arrow because sometimes people think that, oh no, the arrow must be straight. Yeah, I'm against all those kinds of rules. We're talking about a function as a rule, right? So, but the 3 is going and getting, it's a related to, associated with, mapped to. These are all synonyms. 4 gets mapped to 16. So let's see whether we have visualized every aspect of that definition. Okay, so let's get back. So it says a function is a rule. A function is a rule, okay, that associates, a rule that associates or relates or connects every element of one set, the set called domain. So every element, have we included every element of the domain? 1 is connected, 2 is connected, 3 is also connected, 4 is also connected, and there were only 4 elements there. So we've used that every element, okay? And because I've highlighted that, that means that's an important aspect in the definition, okay? With one element, and that one I've written in bold, okay? With one element of another set. So they are all connected. So 1 is connected to one element in that range. 2 is connected to 4, one element in that range. 3 is connected to 9, one element in that range. 4 is connected to 16, one element in the range. So this is the visual definition, if you were to call it. I don't know whether there's something like that, but we just made it up, okay? Visual definition for functions, okay? Now, if 1 is mapped, sometimes we come across this word also, mapped, or a rule, or an association, or like I said, a relation. They all sometimes, synonymously used. So if 1 goes to 1, 2 goes to 4, 3 goes to 9, 4 goes to 16, think about it. What kind of rule is it? What is the relation? What is the connection between 1 and 1, 2 and 4, 3 and 9, 4 and 16? Could it be that the rule is square of the I'm going to introduce one more word. The domain is also sometimes referred to as input. And if you're going to call the domain input, then you have to call the range output. So if this is how we are going to define the rule, we can say this rule is square of the input. A function is what? A function is a rule that connects or maps or associates or relates every element of the domain, which is called the input, to one element of the range. And in this case, it's the square, this rule, just say f of the input is equal to input square. This is another way to describe this particular example. So let's get back to our definition. It says a function is a rule that associates every element of one set called the domain with one element of another set, which is called the range. Now, in the textbook C, can you see this? They've used the word mappings, okay? We can use set notation, and they've used this set notation. By the way, this particular notation is called Venn diagram. For example, consider the set. This is a set, and they've used the set builder form: 0, plus minus 1, plus minus 2, plus minus 3. This is your input, and they have brought in the letter X. Now, often X is associated with this input, the set of all inputs. Under the mapping, square the number. That's the same example we were looking at. Can you see that? Square the number, all right? So the second set, as I said, this is the first set or the input, and it maps on to this other set called the output. And obviously, you've got 0, 1, 4, 9. Okay, now based on whatever we've done, okay, let's ignore the textbook for some time and just let's look at this Venn diagram. Is it a function? Is every element of the domain involved? Let me just use the word domain here. Is every one element of the domain used? Every element, 0 goes to 0, negative 1 goes to 1, 1 goes to 1, negative 2 goes to 4, 2 goes to 4. Every element has been accounted for from the domain element. So it is a legitimate function. Okay? This is a function. And the reason I'm saying this part right now is because later we will have to deal with examples. It's not a function. The simple idea is the basic idea. The basic idea of what is a function, and basic idea comes from the definition of what is a function. Okay. Again, look at this example here. This is the domain or the input. This first set is the domain, and that's the range. Okay. Is it a function? Is every element of the domain connected to one element of the range? Let's check. All right. 1 is connected to 1. 2 is connected to 0. 3 is connected to 1 again, 4 is connected to 0 again, and 5 is connected to 1 again. Now, every element, that part, that every element of the domain seems to be connected. Nothing's left out. That's fine. But you might say that, hey, 1, 3, and 5 apparently are going to the same element here, and then 2 and 4 are going to the same element here. Is that going to be a problem? Well, let's look at the definition. The definition only says a function is a rule that associates every element. That's the only word that we've highlighted of the domain. A function is a rule that connects or associates every element of the domain with one element. Okay, let me just show that within the frame, with one element of the range. Is that satisfied in this example? Every element of the domain connected to one. So it is a legitimate function. This is a function according to the definition. Okay, let's look at the other example. All right, here we go. This is our input or the domain, and this is our output. Let's look at the definition. Is every element of the domain? 1 is connected to 2. 2 is connected to 2 is connected to 4, and 2 is connected to 8. The definition said every element of the domain or the input being connected to 1. That's a problem, right? This is going to be a problem. 2 is connected to 4, and 2 is at the same time connected to 8. In the same way, we've got the same problem with 3. Look at that. 3 is connected to 6, and at the same time, 3 is connected to 10. That is also a problem. So according to the definition, this is not a function. This is not a function because 2 from the domain is connected to 4 and 8 from the range. 3 from the domain is connected to 6 and 10 from the range. Every element should be connected to one element of the range. On the other hand, if we were to sum it up, okay, remember I said every element. So if that's my domain and that is my range, I just want to make sure that this is seen on the camera. Let me just put down some elements here. So if I've got A, B, and C, all right, and I've got, let's just call this P, Q, and R, all right? A function is a rule that associates every element of the domain. So this one is fine. If I just leave out C, it's not a function. I need to map C to an element there. This is still a function. Every element of the domain, A is mapped to P. B is also mapped to P. But the third element, there are only 3 elements in the domain. The third element, C, is mapped to Q. It is a function. And you might be wondering, what about this guy, R? There's one element in the range that's left out. Well, it is still a function. According to a definition, it's every element of the domain being mapped to one element of the range. Let's get back to the definition one more time before we close this video. A function is a rule that associates every element. Remember I said I highlighted that because that word is important. A function is a rule that connects or associates every element of the domain with one element of the range. So that is a function based on its definition. If you have another way to describe and define a function, do let me know in the comments below. And if you've gained something from this video, please do consider subscribing. I'll see you in the next video.